Hello guys, I'm back. My name is Jeferson Costa, a chemical process engineer with expertise in plant design, and let's start another chemical process engineer diary. I'm just verifying the Instagram if it's working or not. Just a moment, please. Okay, so guys, hello guys, I'm back. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and be welcome to the Chemical Process Engineer Diary. In this series, I share with you my experience as a chemical process engineer. I answer questions and I cover some subjects related to chemical process engineering and plant design. So hello, Poncholi, nice to have you here. And I am doing this live session, this streaming in the Instagram at my left side and also in the YouTube at my right side. And I have three main subjects to cover with you today. And if we have questions during the live session, I'll do my best to answer. So just to let you know, let's talk about what it takes to be a chemical process engineer. I received more than one question related to that in the previous days. Let's talk about plant design at office and also the minimal numbers of trays. What is it and how is the effect that happens in the real life? What happens when we increase the numbers of trays or stages in a column? Okay, so to start with this series, I talked to you a little bit about my daily life as a chemical process engineer, and during this week, I am doing some procedures for a performance test that we will do in a site. So I need to do a step-by-step what will happen during this test. It is very, very important when we are talking about operations that there are some kind of procedures that the operators can follow. So it's very, very common that the chemical process engineer is responsible for writing a procedure to say, before starting the plant, the following valves must be closed, the following valves must be open. Verify if the instrument air is aligned to the process. Hello, Victor. Verify if the pump is ready for running. Verify if the cooling tower is filled with water. So it's very, very common to have in some cases, we have the manual, and the manual is a more generic document talking about the process and the equipment, maintenance, and etc. But we have also the operation procedure, and the operation procedure must have the step-by-step what must be done to run the plant safely and smoothly. So this is one of my activities these days. I will have some meetings also about some troubles that we are having here and how to solve that. And I am doing a technical evaluation of control valves for a system that we want to change the control valve that is currently installed in the field. So this is it. And talking about the main topics for today, let's start with the minimal numbers of stages or minimal numbers of trays if we are talking about columns. So I received this question, I received it in my email, and you can find my email if you want to send some kind of question to me in my website, jeffersoncosta.com. You find links for my YouTube, my LinkedIn, my email, my Telegram, and etc. So all links that is available to talk to me is at my website, jeffersoncosta.com. So here, this question is for Mohammed Hadi, and first he asked me about supervision for his project study. I don't give supervision for people outside of my training program. So the only people that has my personal assistance is my students, but I answer question every time that is possible. Okay, X-Shine, very nice to have you here. So thanks a lot for answering me, sir. I have one quick question. If you could explain to me, how do I know the number of trays to use in the regeneration column of ethylene glycol? I use two trays personally, but I don't know what is the difference. If I increase the trays, what will change exactly? So when he is doing dehydration, he is evaluating the dehydration system. So what is a dehydration system? We have different kinds of process to do that. One of them is about absorption. So we use a solvent to wash the gas, and in many cases it is a hydrocarbon or natural gas stream, and this natural gas stream is saturated with water. So many times when we remove the natural gas from the wells, it is saturated with water. And to add that to the gas grid or to send that to processing, we need to remove the excess of water. We can decrease the temperature to remove the free water that will form during this process, but to get lower dew point of water, we need to use some kind of process. And the absorption is one of them. So we can use TEG to wash the gas and remove the water content that is in this natural gas stream. And it is done in a column or in a tower, depending on how your company names it. But what matters is that you send the solvent at the top, and in counter current from the natural gas, it washes the gas, and the water that is inside the natural gas is absorbed by the solvent. So when we are doing the process simulation about this process, we are able to choose how many stages of equilibrium the process simulation will have. And imagine this. Each stage of equilibrium represents a weight, a h, a space in the column where this absorption is done. So every time that I increase the numbers of stages, my space or my h to do that increases. So if I have one, I have two. So now I doubled the h, and because of that, I increase the time that my solvent can absorb the water. So it means that as many stages I have, more efficient will be my solvent to remove the water in this case. Okay, but when we are talking about sweetening, removal of HOS and removal of CO2 is the same principle. And but there is a limit to that. I can have one, I can have 5, 10, 100, but there is a limit. If I consider 1,000 numbers of stages, it still has a limit, and in many cases the curve of performance is this way. You get this way. So there is a limit or that we are not able to reach, although we add more and more stages. So this is a point. When we are talking about distillation, we can use the shortcut column in the Aspen-High-C. So there, the Aspen-High-Cs will calculate to you the minimum number of the minimum number of stages that the Aspen-High-C suggests you to start with. So this is the easiest way to verify what are the number of stages that you will consider. When we are talking about absorption, there is no a straight run to verify that, but you can, with the letting the streams fixed, you can change the number of stages and verifying the results. You don't change the conditions in the solvent stream, you don't change the conditions in the gas stream, but you verify based on the increase in the number of in the number of stages, what happens in the results. So these days I did research about the gas sweetening for biomethane production, and one of these papers had shown to me a curve, and based on projects that I have experienced, in many cases the hydration column usually has around 80 stages of 80 stages of equilibrium. So this is, you can verify that by yourself. Do the test in the Iceman High C, and you can build your graph to verify what happens. Okay, but in the process simulator, I can add as many stages as I want, because it is a process simulation. You are not expending any kind of money to do that. However, as many stages you have in the column, it means that your tower or your column in the real world will be bigger. And the diameter is a function of the flow that is available to go to the column. So the diameter is more or less fixed based on the amount of flow that you will pass through the column. However, the H of the column depends on the efficiency that you want to your process. But as bigger or as taller it is, more the size is bigger, more material needs to be expended. So if imagine that instead of using one ton of carbon steel, you need 1.5 tons of carbon steel, or 2,000 tons of carbon steel. So the capex to install that column gets bigger, and depending on the cost benefits, that can kill your project. So there is a balance between the number of stages that you need to your process and the efficiency that you can have, and also the money that you can expend to achieve that efficiency. So that's the point when we are doing the process simulation software. It's not only a matter of having adding a lot of stages to get the purity that we want. The chemical process engineer must understand that it represents more costs in the field, because you will have a bigger equipment, and because of a bigger equipment, that it will be more expensive. It is more expensive. The capex of the project increases, and that impacts the present value and the economics of the project. So keep that in mind. Okay. The other question that I received in my social media, and this time it was in the YouTube, and it was very nice because usually I don't have Brazilians in my content, and this question was addressed by a Brazilian guy. So he asked me if the question is chemical to work with plant design, the chemical process engineer must obligatory work in a office. That is the question. It's in Portuguese, okay? So I will not be able to read straight to the point to you. So the matter is, to work with plant design, you are not obligatory to be in an office. It depends on the company and depends on where you are. If you are in a IPSI company, most often you will be in a design office, because you will be dealing with papers, documentation, and calculations, and you don't need to be in touch with the process. You don't need to go to the field necessarily to develop your deliverables. just to let you know, I work with plant design, and because of the pandemic, I am almost 1 year doing home office. So it's rarely when I go to the field. I went to the field one time since the pandemic starts here in Brazil. So it's not obligatory to work to so you don't need to be in the field every day to develop your job as a chemical process engineer working with plant design. However, there are some companies that has and it happened to me. I started a project in a polypropylene plant. It was a revamp, and after that I was invited to join their design department. And the design department was inside the plant, in the plant, was in the facility. So there was the administrative, there was the control room, and there was a room for the design team. So in this case, I was dealing with my roles as a chemical process engineer for plant design, but I was inside the facility because all the team was inside the facility. It was part of the company, the production company, the design team. So this way, it's nice because the project is usually it is for small projects. It is nice because everything, any changes that you do in the design, you can follow the installation, you can follow the commissioning, you can follow the startup and the performance, and you can verify if it happened, what was good, what was not good, and you can improve your skills better based on the field experience, and that's very, very nice. Sometimes when we are only in the design office and we don't go to the field to follow what was installed, lessons that was learned during the erection is not you don't receive that, so you don't understand if I participated in a project in the installation commissioning of a nitrogen plant, a air separation nitrogen plant, and in a cryogenic process. And one drain valve was specified as ball valve for this process. So during the startup, we needed to do the drain of this column, and because the type of the column as being a ball valve, it is not suitable. It's not suitable for cryogenic process because of the cryogenics. It dilates the metal and it starts leaking. And I was able to see that with my own eyes. So I reported to engineering team that was in the US. I recommended to not use that kind of valve anymore, because I have seen what happened. The guy that was in the office in the US are not aware of that because he used the ball valve for some reason. I don't know the reason, but he used it. Okay, so based on that, my other projects, I would remove the ball valve and install another one like a gate valve or a globe valve for cryogenic service. It needs to have steam higher than normal and etc. So this is the nice part of doing the design inside the facilities, or when we can follow what happens in the field. Okay, so to answer the question, you are not obligated to be in a design office to work with chemical process engineering plant design. In many companies, the team is inside a plant. It is inside the plant, it's inside the facility, and you support not only the design but also operations sometimes, and it is very, very good for building experience and developing a career for the chemical process engineer. And guys, If you have a question, let me know. Let me see. I talk a lot when I talk about chemical process engineering plan design. I have seen that Hishab just entered the Instagram. Nice to have you here, Hishab. So let me see if we have any question in the YouTube. Any question in the YouTube and any question in the Instagram. So let's keep going. The next topic that I will talk to you, and it is the last one. In a few minutes, I will start my working day here in Brazil. So, okay, I have 15 minutes left. I received a question from Anurag Shrimali. Probably he is Indian. There are some kind of names that I'm not able to pronounce. Okay, sorry for that. So first he asked me, sir, I want to become a chemical process design engineer. So, sir, can you suggest me what is the qualification required for becoming chemical process design engineer? Sir, I am studying diploma chemical engineering. So, sir, what is the next step for that? Important. What I would like to share with you is the importance of understanding what is the minimum requirements and what you can do after your graduation. Here in Brazil, for instance, to be able to work as a chemical process engineer, we need to do a bachelor degree, and the bachelor, by the regulation here, by the laws of Brazil, the bachelor allow me to work as a chemical process engineer. But if I want to keep studying and adding more titles to my current diploma, I can do a specialization, I can do a master, I can do a PhD, wherever. Hello, Jonathan, I can do as many post-graduating as I want to, but that will not change the fact that to work as a chemical process engineer, I just need the bachelor. So the bachelor is that will give me the right to be hired as a chemical engineer. Okay, so I am not aware of all roles around the world, but it seems that to be diploma chemical engineering. If you are diploma chemical engineering, you can get a job as a process engineer. You are able to, the government says that you can be hired as a chemical process engineer. However, if you want to, you can improve your knowledge. And you can improve your knowledge by courses and presential courses, online courses. You can do specialization. Here in the India, there is the BE chemical engineering, and there is the BE, there is the BTech. So if once you have the permission of the government to be hired as a process engineer, that is enough to be hired as a process engineer. But you can improve your knowledge, and you can improve your knowledge adding to your resume more courses, and that can be specialization or BE engineering, or you can do a master, you can do a PhD, and etc. But what is the point here? The point here is that titles don't guarantee you results. It's very, very important that you understand that what companies want to is results. You can be a PhD in quantum chemical, I don't know. You can be a PhD in something related to chemical process engineering, but if I need or Wally Parson needs to hire a chemical process engineer to do plan design, if you don't know how to read a pipe instrumentation diagram, what is the matter of I hire you as a PhD if you don't know how to do process simulation, you don't know how to read a pipe instrumentation diagram, you don't know to do a process data sheet for equipment, doctor in chemical engineering, that's the name. Thank you, thank you. So it's important to you look for titles if the titles will give you some kind of knowledge to improve your results. It's that is very, very important to you understand. Don't collect titles only because of the titles. You need to collect knowledge, and knowledge is only knowledge if you are able to apply them. So I will answer your question, okay, Akshay? And so I'm pretty sure that many of you can improve your knowledge in chemical process engineering and plant design only with my playlist, my chemical process engineering diary playlist, and also my Jefferson 9 a.m. playlist, because there are a lot of knowledge there that you don't find in the books, you don't find in doctoral courses, because the target of the doctoral courses is not to do plant design, is to prepare your mind to know how to do research, how to interpret, how to do. Many of them is related to research. As you get higher in the academia, more addressed to research you are. Here in Brazil, we have some kind of understanding. I don't know how to say it in English, but if you want to be a teacher, you will do a master. If you want to work in the industry, you will do a specialization. It's something like this, okay? It's not totally true. Of course, there are exceptions, but in some cases, the industry looks this way. So take care about adding titles to your resume if you are not improving results in your resume. So that is something that I would like to alert you about that. Okay. So I have a question about Akshay. So what is Six Sigma? How important it is? It is relevant to process engineering. Nice question. Nice question, Akshay. Six Sigma is a methodology to decrease the number of defects that you have in a process. So if I have a manufacturing process and in 1,000 products, I have, for instance, 100 deviations, I will use the Six Sigma methodology to decrease that. Instead of having 100, I will starting implementing Six Sigma to decrease that for 50, 100 to 10, to 100 to 50 to 10 pieces, and with that I improve the quality of my manufacturing. Most often we use in fact, the Six Sigma was born in the manufacturing industry, in the automobile industry, but after some time it was spread out in the world, and now currently people use that in administrative, people use that in many areas where we can measure the results and we can decrease deviation. So the main subject of the Six Sigma is to decrease deviation. And how important it is for chemical processing or chemical engineering depends on if you work strictly with the chemical process engineering in plant design. If you are not in the quality department of the chemical process engineering plant design, it is not so useful. It's not worthless, but it's not so useful. Anyone will hire you to work with plant design because you have a Six Sigma master black belt, okay? That's not happen. However, if you are a chemical process engineer that works with operations, in the operations you collect a lot of data. you have a lot of data, and you are able to evaluate if any changes in the process will lead to a decrease in the defects or the deviations that you have in the process. So in this case, the Lean Six Sigma, the Lean is another methodology, and the Six Sigma is a methodology, but in many cases they get both together to improve the performance of the operations. So if you are planning to work with operations, I recommend you to get familiar with Lean Six Sigma, because that way you will have a different approach to the problems that happens in your process. You will see the data, you will collect the data, you will be able to organize them in a way to verify this temperature is increasing too much in my process, although the design says that it should be 50 Fahrenheit, but it is always increasing, and I'm losing the product specification because of that. What can be done to solve this? So the Lean Six Sigma will help you to solve this kind of issue, okay? Hello, Alaneros, very nice to have you here, my friend. So guys, my time is short. I have just 5 minutes. I will answer last question, okay? So let me hear. I have here a message from Jonathan from Germany. It is very interesting that what Jefferson just said about the titles engineer should look for depends on the country. As he just said, for instance, in Germany, it's very easy to get a job in industry, have the title of doctor, nice. But in Latin America, that does not happen. PhD is maybe too much to work in industry in Latin America. Yes, you are totally right, Jonathan. Your comment is totally right. Everything depends on where you are or to where you want to go, okay? So you need to do a research to verify it, as Jonathan says, you want to go to Germany. So here, what I see in the Jonathan comments. So to equalize your chances with natives, the doctor in some way can be the minimum that you must have. Okay, so in Brazil, if you have a doctor, it's something that is far away from the average people. Let's say the average engineers don't have doctoral, so you get too distance from that, and not necessarily that is good for you. Okay, depends on your objectives. And in Germany, as it is easier to get a doctoral, there will be a time that everyone has that. So if everyone has a doctoral, and of course that depends on the recruiter, okay? I'm just generalizing here. If everyone is doctoral, why I will choose someone that doesn't have doctoral? And okay, so that's it's very complex. The job market is very complex, but remember that it is a market that relies on demand and scarcity. Okay, so my time is finished, guys. Very nice to have you here, and I hope to see you soon in the next live session on Saturday or in the next Tuesday. So I hope you like it, and bye bye.